example in which the only obstacle is that the power of the unknown is not equal to 1. It says x to the power 2 is equal to 49. Let's see how to solve this type of problem. Please cooperate with me. As you see on the board, the example h is given by x to the power 2 is equal to 49. With this example, we wish to learn how to clear powers. Don't forget that not having power of 1 by a variable is one of the obstacles a variable can have when it exists as a part of the equation. In this case, we have x to the power 2 is equal to 49. So we learn how to make this power 2 become power 1 so that it conforms to the notation of x as we learned earlier. Every other thing is okay with this x except that its power is equal to 2. Notice that it has 1 as its coefficient but not shown. It is plus but not shown. It has 1 as its divisor but not shown. It has 0 as its adder but it is not shown. But the only obstacle it has is that this 2 is its power instead of 1. Therefore, we learn correspondingly that the only obstacle is that the power of x is 2 instead of 1. So in this example, our assignment is to carry out a process, to carry out an action that is meant to clear that power and make it become power 1. So how is it to be done? There are two major approaches to clearing powers. That this is power 2 is just typical of this example. It is possible for us to have other examples where we have power 3, power 4, power 5, as we had in the beginning of this lesson. Now, how do we clear powers? Anyway, there are experiments that could be conducted that will show us that if we want to clear powers, what we should do is to find the same degree root of that power. What do I mean by the same degree root? This is power 2, for instance. So what we're going to use to clear it is square root. If it is power 3, what we're going to use to clear it is cube root. If it is power 4, what we're going to clear it is fourth root. If it is power 5, we're going to use the fifth root to clear it, and so on and so forth. That is what I mean by saying that we clear powers by using the same degree root. Don't forget that if you write square root, for instance here, this sign I used this place is a sign of square root. And square root is supposed to have 2 here to indicate that it is second degree root that we are looking up to. Second degree root is called square root. Third degree root is called cube root. The fourth degree root is called fourth root. The fifth degree root is called fifth root, and so on and so forth. So why are we employing square root? If we use square root, we don't normally show the 2, which is supposed to be here. So 2 is supposed to be here. 2 is supposed to be here also. But because square root is the simplest of all the roots, many times we choose not to show it. So at this point, 2 is supposed to be here, but not there. Just bear it in mind. From cube root, we start putting 3 here to fourth root to fifth root, we start putting 3, 4, 5 as the case may be. Therefore, this sign of square root is a simplified one. The complete expression, the complete notation of a square root is this small thing that resembles a house, then 2 here. That is the complete expression of square root. Now, the first method of clearing powers from variables when they appear in equation is to find the same degree root of that variable. Like I said earlier, because this is root raised to the power 2, it means that the power is degree of 2. That is second degree. That is why what I'm going to use here is square root. So watch me as I applied it here. This is square root of, which means there is something new happening to this equation. What is it? This square root did not exist in the question. I introduced it to achieve a goal. What is the goal? The goal is to make this power 2 become power 1. And it is this square root is one way or one of the instruments that we can use to make it become power 1. Therefore, I employed it here. Don't forget that anything you do to left-hand side of an equation that changes the value of that left-hand side must be repeated at the right-hand side. This is exactly why the same thing was done to this right-hand side. If I do it here and I refuse to do it at this right-hand side, what I will have after everything is not going to be an equation. It will be an inequation. All right, so I introduced square root to achieve a goal. I've told you what the goal is. Left-hand side, right-hand side. Again, check what is new in this expression. What is new is the square root. Where is it coming from? It came from my reasoning. It came from intuition that one of the ways to clear square is to use square root. One of the ways to clear any power is to use a root sign. This root sign is peculiar to square root. And after doing that, whenever a number is raised to the power 2 and you find its square root, the result is that same number raised to the power 1, which means that the result we get from this expression here is x to the power 1. And the result we get from this right-hand side is 7. What does square root of 49 mean? I will get back to it later. Now, at this point, we can demonstrate by means of experiment that the square root of every square is that same number. The cube root of a number is that same number. The fourth root of a number raised to the power 4 is that same number. The fifth root of a number raised to the power 5 is that same number. What it means is that the square root of something squared will be equal to that same something. That is why x to the power 2, its square root is equal to ordinary x. Don't forget that this x to the power 1 is the same thing as x. Okay, so this is the first method. What about the square root of 49? I believe you know what a square root is. A square is a number we get when a number multiplies itself. If you say, for instance, 2 times 2, the result is 4. That number 2 that is multiplying itself is called square root. That is the root where the square started, while the 4 which you got after multiplying it is called the square. So if you say 2 times 2, 2 is the square root, while 4 is the square. Again, if you say 3 times 3, the square is 9 and square root is 3. If we say that the square is 9 and square root of 9 is 3, it simply means that when 3 multiplies itself, the answer is equal to 9. Therefore, whenever somebody is asking you to find a square root of something, what is he asking you to find? He is asking you to find a number which, when it multiplies itself, appearing twice, that number will be gotten. For instance, here I have square root of 49. What do I mean? I'm simply asking, what number multiplies itself to give us 49? Surely the answer is equal to 7. Perhaps without using calculator, you can find the square root of a number using the pairing system you learned in the primary school. If you cannot, today you can simply punch this square root of 49 with calculator or any other electronic device that can be useful. All the same, it is important to know that square root simply means a number that multiplies itself. A square is a number that we get after a number multiplies itself. Therefore, the square of 7 is 49, and the square root of 49 is 7. Therefore, this root of 49 is equal to 7. And I said earlier that square root of a square is equal to that number that is squared. Therefore, x is squared. Its square root is equal to x. Square root of 49 is equal to 7. So after we simplify left-hand side and right-hand side of this operation we're carrying out here, we are left with this resulting in this and this resulting in this. This is the first method. Perhaps we will need another example where we have to talk about the cubes and cube roots, raised to the power 4 and the fourth roots, and so on and so forth. Let me try to make you understand the second method. Second method is offered here. Second method of clearing powers is to raise that power to the multiplicative inverse of that power. If you want to clear a power, what you should do is multiply the entire index, that is, raise the entire index to the power of the multiplicative inverse of that power. X to the power 2 altogether is called index. This is called index. Okay? Then this 2 on top is called its power. Then, to get these two cleared, mathematically, if we raise it to the power of the multiplicative inverse of these two, eventually we'll still land at this x to the power 1 or x raised to the power 2 over 2. Just watch it, please. 2 times 1 over 2. If what you have here is 3 as a power, what you should do is to raise the whole thing to power 1 over 3. If what you have here is 4, what you should do is to raise the whole thing to power 1 over 4. If what you have here is 5, what you should do is to raise the whole thing to power 1 over 5. But what we have here is 2. So we raise the whole thing to power 1 over 2. Now, use the principles of multiplying fractions to simplify 2 times 1 over 2. Don't forget that these 2 here can still mean 2 over 1. So 2 over 1 times 1 over 2 will lead us to 2 over 2. Do you agree with me? In fact, if you are following what I'm saying and you have also read your fractions very well, you will not be in doubt as to whether I am correct here or not. You will know I am correct. Now at this point, 2 times 1 is equal to 2. Then 1 times 2 is 2. So 2 over 2 will still give us this 1, giving us x raised to the power 1. Therefore, this is why we got this single x, which is x raised to the power 1. This way, that power 2 has been reduced to power 1. And once it becomes power 1, it becomes ordinary x, written for convenience. All right. What about the right-hand side? Whatever new you do whatever new thing you do to left-hand side that causes a change in value of the left-hand side must be repeated on the right-hand side. And this is exactly what I want to do at this point. So what is new in this line is that I introduced raised to the power 1 over 2. It was not in the original question, but I learned that I could as well use this method to make these two become 1. Don't forget that when a number multiplies its own multiplicative inverse, that the answer is equal to 1. Is it not these two that you want to become 1? Yes, which means whatever you do that makes it become 1 is applicable, and that thing is mathematically correct. One of them is to multiply it by its multiplicative inverse. That is why I brought 1 over 2, because 1 over 2 is the inverse of these two, so that when they multiply, the result is this 1. The same thing should happen to right-hand side, raised to the power 1 over 2. That new thing I brought into left-hand side is what I brought into the right-hand side. Now, students, check very well. Why then did it become 49 raised to the power 0.5 here? It is because if you convert this 1 over 2 to decimal, what you're going to get is 0.5. It does not mean that this is not possible to evaluate, but with calculators, especially when it is not in the mode of fraction, it is better to use decimals in this operation than ordinary vulgar fraction, what we have it here. So this 1 over 2 is a vulgar fraction, and to simplify the punching of the buttons of calculator, we have to convert this 1 over 2 to 0.5. Try again and check whether 1 over 2 is the same thing as 0.5 if you convert 1 over 2 to decimal. At the end, you will see it is correct. Therefore, when this is evaluated, we have this. When this is evaluated, we have this. So with calculator, you will now know that 49 raised to the power 0.5 will give us 7. Please try it out. 49 raised to the power 0.5 is equal to 7. And x raised to the power 2 over 2 simply means x raised to the power 1 over 1, which is equal to x to the power 1, which we have here. Then eventually, in the simplest form, we have it as x raised to the power 1, or just ordinary x. So whether it is this method or this method, the answer is the same thing. What is it? X is equal to 7. Now, let's see whether we can do the same thing to other powers apart from power 2. Watch out, please. Okay, this is another exercise, another example that we want to have, so that we have the opportunity to know more about how to clear powers. I'm giving this example because the first example I gave under this example H was x raised to the power 2. Now we have x raised to the power 3. We want to know and learn by means of this example that it is possible to clear other powers apart from power 2. Now watch the board and you'll find a question: x raised to the power 3 is equal to 125. You can see a corresponding statement that says that the only obstacle we have here is that the unknown, which is x, has power 3 instead of being power 1. Again, we ask, how do we clear this obstacle? That is, how do we make this power 3 become power 1? Again, I want to inform you that there are two different methods that have been identified so far. The first method is find the root of that variable raised to the power something and do it to both sides of the equation. Second method is raise that entire index to the power of multiplicative inverse of the power which already exists, which means to clear powers, we find roots. or we use multiplicative inverse of the powers. Let us look at the first method, which is using roots to clear powers. This is x to the power 3. I want this 3 to become 1. What must we do? Are we still going to use square root of that x to the power 3? The answer is no. If it is x to the power 2, we will still be right to use square root of x to the power 2. But because what we are seeing here is x to the power 3, only cube root can clear it and make it become power 1. Therefore, I am introducing a new operation into this x to the power 3 to achieve a goal. The goal is to make power 3 become power 1. One of the ways that we can convert that power 3 to become power 1 is to find its root. And now, the correct root should be cube root. Look at the sign of cube root. So this sign is now introduced into this operation. It had not been there before. It is something new. Who told me to bring it in? It is because I identified it as one of the different methods, tested methods of converting powers to 1. And my intention is to convert this power to 1, since it is the only thing worrying this x here. Therefore, cube root sign is what I'm seeing there. This 3 written here shows that this sign is not a square root, but a cube root. If 4 is what is here, the name will be called the 4th root. If 5 is what is here, the name will be called the 5th root. Be very careful that you write this number exactly where it should be written. Notice where it is. It is not outside this sign. It is within the sign. If you write this 3 outside the sign, like somewhere here, what you have written has a different meaning. Then it will mean 3 times square root of x to the power 3, no longer the cube root of x to the power 3. Therefore, anything you place outside here is now multiplying the root, no longer defining the root. I want this 3 to define the root and not multiply it. That is why the 3 is written within. There's something applicable here. I hope you know. I hope you are following what I am doing here. Now let's make progress. Look at this law that is going to help us get the answer. Look at this law here that says the nth root of a number to the same power is equal to that same number. Here, x is any number raised to power any number. As long as the root is the same thing as the power, that is, if the root corresponds to the power, the answer you get at the end is that same number raised to power 1. For instance, here, our x remains the same x here. Our n is 3. See the 3 here and here. See n here and here. So this is the formula of clearing powers from variables. So I want, if we say clear powers, I mean change powers to 1. So let us apply this formula to clear the power from this x to the power 3. Then after everything, the result should become this thing, that is x to the power 1, which eventually, when written in a simple way, will give us something like this, just x alone. Therefore, what are we going to do? Since this has become this, the same operation, which is finding the root of the number, should be carried out on both sides of the equation. And this is why it is extended to what we're seeing here. Here, cube root. Here also cube root. What is the cube root of 125? It is equal to 5. What do we mean by cube root of 125? It simply means find a number which multiplies itself, appearing 3 times to give us 125. Of course, The number that multiplies itself and appears 3 times to become 125 is 5. Therefore, the cube root of 125 is 5. As a result, the outcome of this operation is x, or x to the power 1. The outcome of this operation is 5, either way here, either way, 5 here or here. Now, I believe we are through with this first method. That first method is, if you want to clear power, use roots. Look at how to use the root to clear powers. Next will be to use second method. That second method is by use of the multiplicative inverse of the power. This is the power of 3. We are going to multiply that 3 by its inverse. Its inverse is 1 over 3. What it means is that 3 times 1 over 3 will give us 1. Don't forget the meaning of a multiplicative inverse. It is a number which, when it multiplies a number, yields 1 as the result. It means that the inverse of 3 is 1 over 3, and the inverse of 1 over 3 is 3. They are the inverses of each other. So this is now 1 over 3, which I introduced into the process. For which purpose? To achieve the same purpose of converting this power of x to the power 1, because once these two multiply, the result will be equal to 1. Please use the principles of multiplying fractions to ensure that you get 1 out of this process, as it is shown in this expression. The same thing is applicable to the right-hand side, which is 125 raised to the power 1 over 3. Don't forget that I introduced 1 over 3 to the left-hand side, and the value will change. That means the same 1 over 3 has to be introduced to the right-hand side, and both are powers of those terms found in both sides of the equation. Right now, in the earlier example I gave, the time I gave x raised to the power half, I was able to convert 1 over 2 to 0.5. That 0.5 is the exact value of 1 over 2, but it is not going to be advisable to convert this 1 over 3 to 0.3, because it is going to be 0.3333. So whatever you get out of it is going to be approximated, and that is not what we are looking for. We want to get an exact value of 125 raised to the power 1 over 3. What then should you do? Please use calculator and set it in the mode of fraction. That way you can punch your buttons to get 125 raised to the power 1 over 3. If you punch the right buttons and correctly, then you're going to get that the answer is equal to 5. Therefore, either way, the answer is that x is equal to 5. In summary, whenever you want to clear powers, use roots to clear powers, or use multiplicative inverse of the powers to clear the powers. These two examples are sufficient for now. Please look out for an exercise. All right, look at the questions on the board. It says use roots and or multiplicative inverses to clear powers from the following equations. These are the equations. It thinks use any of the two methods that you have been taught, which I believe you have learned, to clear the powers from the following. Personally, I would suggest that we practice more of using multiplicative inverse to clear powers than using roots. It appears to be faster in many cases. The only time we think about using square root or cube root or more is when the power is a kind of whole number power. For instance, this 2, we can easily use square root to clear both sides. This is to power 3. We can also use cube root here. We can use the fifth root here. But when it comes to fractions as the powers of the unknown, it becomes more challenging. That way, I recommend that you use the other method, which is the use of multiplicative inverse. It's okay, we have x to the power 2 is equal to 64. Clear this power and make it power 1. C to the power 3 is equal to 343. That's number B. Clear the power of this C and make it C to the power 1. Then number C says y to the power 5 is equal to 32. Make power 5 become power 1. The next is x to the power 3 over 2 is equal to 729. That 3 over 2 is the power. You better use 2 over 3, which is its inverse, to make this become power 1 and do it to both sides, than insisting on looking for the square root of this x and then later raising it to power 3. It is cumbersome. So I again recommend that you use multiplicative inverse instead of outright root. The fifth one, that's number E, is m raised to the power 0.8 is equal to 10. Please convert this 0.8 to first vulgar fraction before you can look for its inverse, and then you can go on to solve it afterwards. All right, please, I believe that you get the correct answers to these questions. That's because I have the confidence that you listened while I explained all I did in this part.